So, what are the problems? I have to, specify some sub-problems and then go to my main problems. The hard problem is that this classical problem of induction. Inverse problems, you don't observe the generator, you don't know what processes you're dealing with. There are a series of smaller problems that we can probably solve for. Is something called the ludic fallacy, the fact that probabilities are not observable in real life as they are in games. You had to. There are a lot of problems associated with my general thing, but my main point is that small probabilities are not measurable. Now, what do? My solution came in the following way. All right. There are two kinds of decisions you make in life. Decisions that depend on small probabilities and decisions that do not depend on small probabilities. For example, if I'm doing an experiment that's true-false, okay, I don't really care about that pi lambda effect. In other words, if it's very false or false, it doesn't make a difference. So, for example, if I'm doing tests on individuals in medicine, I don't really care. I'm not affected by tail events. But if I'm studying epidemics, then I have a random variable. How many people affected becomes open-ended with consequences. So therefore, it depends on fat tail. So I have two kind of decision. One simple, true-false, and one more complicated, like the ones we have in economics, financial decision-making, a lot of things. I call them M1, M1 plus. And then we have also, as we saw, two types of world. I have a world of thin tails and a world of fat tails. Okay, two worlds. And I discovered the following, and this I learned from dealing with statisticians, is if you tell them your techniques don't work, they get angry. But if I tell them this is where your techniques work, okay, they buy you Diet Coke and be nice, and they say hello, all right, in the elevator. So I tried to make a map of where there is what I call the black swan problem, is when you have complex, decisions that are affected by how important the move is, and we can't really compute small probabilities. So there are four quadrants. That fourth quadrant is the limits of where we can, do things. And I think that we need to do here, that's my hard problem, is try to define how to be robust, what robustness means to black swans, and how you could be robust to the black swan in this quadrant. Okay, we cannot escape it, unfortunately, in finance. Ever since we left the Stone Age, our random variables became more and more complex. We cannot escape it. We can become more robust. There are techniques to become more robust. I rewrote, the Black Swan. I was bored with it, so I decided to rewrite it, and so I added about 100 pages on robustness. Okay, the notion of robustness became my obsession. So, how to be robust? It's not clear. It's a hard problem, and that's my problem. Thank you very much.